All right, just looking. Oh, okay, perfect. Never mind. It matches up now. We were missing one student in the Desmos classroom. Someone just logged out, so I hope that that matches at least. Looks like we're all in. If you're not into the class, please let me know. And we'll go ahead and take 2 more minutes with this production activity. Then we will get started. And the last question, I think I'm seeing more talk to animal people than I am speak languages. I've got a few questions in the chat that I'd like to answer right now. First question I'm seeing, will we get the links to the teacher versions of these activities? Yes, we will. And that's our 2 minutes for finishing up this. Let me stop that timer. We love the built-in Google timer, but we hate the tone it makes at the end. Anyways, yes, I'll be sharing all of these activities at some point today for sure. So you can see sort of the background behind it. I will, at some point today, also give you a tour of what I'm looking at right now while you all are looking at this. That was one of the reasons for doing this actually, is so that I could share a nice teacher view of what's going on without having to share, my own students' names or anything like that for past activities we've done. So I'll share that side with you. You guys will get the teacher versions of everything we do today. I'll share Google folder with all presentations that are there as well. Eric, you got a surprise that there is no "you are done" slide in this activity. That is correct. They won't put a default "you are done" slide. You are certainly welcome to make your own. I did not. But yeah, there's no you are done. You did the thing slide built in by default. Just, at the top it says how many total there are, right? I like the idea of using this for community building, getting to know you at the start of the school year. Definitely. Yeah, no, that's great for that. There's lots of fun things. The first one with little robots, I didn't make that. I stole, in fact, a few of these. Desmos has some sort of community building pages that you're seeing here. And so I use some of those. And so some of these you don't have to create, they're just there, but it's a nice way to share with everyone. While everyone I know agrees virtual learning was worse, you know, one of the nice things for me at least was things like a chat where everyone can share and you have sort of that record. And so that is nice. I think there is some aspects of that as well. And I am joining you here from Missouri, where I'm in northern Missouri. It's southern Missouri where it's happening, but the Delta variant is surging in our state right now. So some possibilities of being at least partially virtual next year are looking more possible too. And so having tools where you can share across virtual and at-home students like this, unfortunately, is a reality that is useful. Yeah, thank you for the sympathies. It is what it is, right? At this point, I got to roll with the punches. That's how this goes. All right, so let's go ahead and get started. Desmos for the Physics Classroom. We're here. We're doing the thing. I am excited. My name's Joe Miliano. I want to introduce myself a little bit more besides the guy who tweets too much about physics teaching. Give you a little bit of introduction about myself, talk about what we're going to do, where we're going to go, sort of set some expectations for the workshop to start us off. And so this is me. A little bit more about me. Currently a teacher at Clayton High School, and by currently I mean I am starting there up in the fall, so I haven't actually really stepped foot in the building yet. There's never too much tweeting about physics, and this has been a masterclass in rolling with the punches. Both of those are true, accurate. Yeah, so I'll be at Clayton High School next year. Super excited about it. For those of you who are in the modeling community and have been for a little while, I will be at the school and probably in the classroom that Rex Rice taught in. They've got a huge modeling culture there, which is one of the things that drew me to moving to that school. They also do physics first, and all freshmen take physics. And I'm excited about being at a school where that is a science that's valued enough for all students and not just the select few that choose to take it. So super excited for that move. In the past, I've been at Parkway West High School. That's also in the St. Louis area, a little bit further out west in St. Louis County. And then prior to that, I was at Lee's Summit West High School, which is, I wouldn't say in Kansas City, it's near Kansas City. It's about 40 minutes out. So I've taught, when I say I've taught freshman physics, I mean I'll be teaching freshman physics for the first time this upcoming year. Very excited about it. I've been working a program for middle schoolers for the past couple of weeks, and it's for 7th through 9th graders. And that age group, they're dope. Like, they are a super cool group of kids, like trying to figure out who they are, what their passions are, and so I'm excited for that. But I've taught sort of a regular junior level physics class. The only AP physics I haven't taught is E&M, and I don't, if I had a choice between that and 2, I'd always choose physics 2, I think. So I don't see myself seeking out AP physics C, E&M anytime soon. Help out with robotics, help out with theater, some teams engineering stuff. Helped out some with our ASAP, which is for our Black student population, helping them and supporting them some more. So lots of cool stuff. I'm also a tap dancer, which is not something I tweet about a ton, but I love throwing that little fact in there because this feels like a hard right turn. Been doing that since I was 6 years old, so forever now. Yeah, it's super fun. Been teaching it on and off for the past 6 or 7 years. It's a great time. And then I'm on Twitter too much. Follow me. That's probably how you're here, if I had to guess. I did no other advertising. All right, so that's me. I want to talk next about what we're going to get out of our session here together. So these are my goals on the screen here. I want to start off by just talking about using Desmos as a calculator because that is its primary function. And for me, like, it has replaced ever encouraging a student even really to like use a TI 83 or 84 or Inspire, whatever they have. Like, if they're familiar with it, of course, let them. But if I am teaching them to use a graphic or a calculator, I am teaching them Desmos. That's what I am choosing to do. We'll talk about plotting and analyzing data. I have also moved to anytime we are using a computer to make a graph to plot our data, Desmos is the tool we're using in my classroom. And we do it because it's very intuitive and very quick and easy for students to pick up, which I value. I think the downside to it, I think the alternatives are either Logger Pro or what's the new one, graphical analysis, or potentially using spreadsheets. And in particular, spreadsheets I think are a very valuable skill, and I do think that's a trade-off that I've made of not teaching spreadsheets in my classroom. But the trade-off of seeing the data visualized in a nice, easy way, and some of that lack of frustration really helps us focus on the physics, I feel. And then we'll talk about the activity builder. You'll get experience with the student end of the activity builder first. We already had some of that experience. We'll do more practice with that this morning. We'll talk about the teacher end of that first, what it looks like just when you're doing activity. And then also we'll talk about building activities. So that's kind of where we're going. And my goal for this morning is not necessarily expertise. My goal is that you feel familiar and confident enough with all of the tools that you have access to that you can start playing around on your own if you're not there. So that's really what our goal is this is something that, once you have an idea of, oh, I want to try this, you know that you'll be successful in playing around, maybe, forget something, come back and look, but you'll be able to do that. Those are our goals, is to have familiarity. So some norms for our groups here. As always, take an inquiry stance, right? Look at it with a critical eye, ask questions, all that sort of stuff. Number 2 here, I want us to understand, we've got various levels of experience. We have complete beginners in this Zoom who have never used Desmos before, ranging from people who have significant experience. And so nothing we do today will be, I think, valuable for everyone, if that makes sense. And so we'll start off, if you have some familiarities at the beginning of this the beginning of this workshop, will feel very familiar and maybe a bit slow and boring, but it'll be helping people who have never seen Desmos. And then by the end, especially if you're hanging out for session 2, if you're brand new to Desmos, maybe some of that might feel a little challenging, but you've seen it and have some exposure to it. So that's sort of the scope we're doing. I do feel that everyone here will get valuable things out of it. And so it's going to be different for everyone depending on your level of experience. We'll start on time, we'll end on time, we'll take breaks as needed. I can usually focus for about an hour. If I'm in a room with other people, I can usually focus for 25 minutes if I'm on a Zoom. And we'll probably do things for longer than 25 minutes here, but we will take breaks for sure. I mean, it's necessary. No one's going to sit in front of a computer for 3 hours on a Zoom. By no one, I mean, maybe you can, but I can't. Ask lots and lots of questions. We'll use the chat mostly for our question format, ask them there. But if you have a question that needs to be answered in real time, like, please, I do encourage unmuting yourself and asking there. And let's see. Expect unfinished business. I always use this norm in almost everything we do. And I think it's valuable to keep in mind that there is a finite amount of time in the world. And as much as we'd love to do everything and learn everything, that's not going to be the reality. So there's going to be some unfinished business, but I am confident that whatever it is that you feel like we weren't able to get to, you will have the skills to explore it yourself afterwards. And of course, afterwards, shoot me a message on Twitter or shoot me an email. You all have my email now. I am happy to help out some more if you have questions. And we're going to have some fun. We're going to do that too. So those are our group norms and expectations. How do we feel about those? All right, seeing some thumbs up, love it. All right, these links will be shared with you. That's why I put them here really, is so that when I share this presentation, you have the links. They'll be in 2 places, but these are collections either made by or compiled by some wonderful people. And as always with teaching, my first recommendation is don't reinvent the wheel. There's great stuff out there, use it, but so I want us to be familiar with that, but also the goal of today's workshop is to learn how to make some of this stuff too, or to take what's there and edit or tweak it for your own classes if there are things that you want to change from those. So you don't have to start from scratch, but you'll have the skills to make changes to suit your needs. All right, and this is more my to-do list than anything else, a reminder of how I want to proceed this morning. So we won't spend too much time there. All right, that's our introductions. Questions before we get started on the basics?
Are you going to send out the slides that have the links on them?
I am. And in fact, right now, while I'm thinking about it, why don't I just do a share here. Here it comes. Anyone with the link can view, copy, Google Drive folder. There it is. And that has the few presentations I'll be using this morning. And the links that I have in that slide are also in that Google Sheets spreadsheet there. So you can just click them from the spreadsheet.
My question is everything free on Desmos?
Everything's free. There is no paid anything. Their business model is such that they really like free access without advertising is one of their top priorities in their business model. The way they make money is partnering with testing organizations and standardized tests and getting their tool to be used in some of those standardized tests. I have dreams one day of Desmos being available and taking AP tests and those sorts of things. So that's where they make their money is there. So it is always free for use for teachers. They follow any sort of privacy rules so that you're not breaking any privacy laws, and there won't be advertising. So that's in their promises and guarantees. Yeah, great question. What else? What else we got before we get started?
My students love it as a graphing calculator because there's also the app, which is free for their phones. So they use it right on their phones. They don't need to have a laptop or computer in class. Yeah,
thank you for sharing. That's exactly right. The app is great. And yeah, it works right on their phones for calculator use. And I want to emphasize that it's free again for just calculator use because a TI-84 is 30-year-old technology that still somehow costs over $100. And this is $0, which is much better. All right, basics. This is as fundamental as I could think of. I won't be doing too many slides presentations. There's a few. Most will be showing you Desmos. But I think there's a few syntax things that can be useful for us as we go. So here's our starting point. Some very basics like this is what you need to know in order to type what you want to type. So first and foremost, while we will be using Desmos maybe beyond its first intended use cases, it is first and foremost a calculator, and that is what it does, which is of course useful in science. And here's a graph that you can make with Desmos very quickly. And I wanted to show you 4 different ways you could make that same graph. So I'll give you a moment to fill up your 4 bullet points there. And I especially like to point this out because as physics teachers, we often find ourselves fighting the battle of students wanting to use X always, when it's often useful to use different variables, right? To describe a physical quantity, you want to use V for speed, not X, because our X we're using for position already. And Desmos can help reinforce that because you don't have to type X and Y to get your graph. You can type in the variables that correspond to the physical quantities you want to plot. And so, so you can do X and Y, but you can do a P and Q if you want to. If P and Q are 2 different physical quantities, I don't know, maybe your momentum is equal to 3, I don't know what Q is. This is nonsense equation for physics, but you can use your variables. You can use function notation, which is also very nice. And the function notation, then once you've typed it in, you can plug in specific values to that function. And again, your function notation does not need to be f of x. You can use blank of blank for anything. Q could be a generalized coordinate, but probably not in high school physics. So the one thing you should keep in mind though is pretty much always Desmos is going to interpret the letter X and Y as being the horizontal and vertical axis variables, which makes sense, but it's important to keep that in mind as a physics teacher because often we want to plot a horizontal position X on the vertical axis. And so that's sort of where maybe our kinematics gets tricky, is that X will be the horizontal axis variable always. And it's not that hard to get around it, but that is important to keep in mind. And then anything else, it's going to do its best. Sometimes if you feed it something that confuses it, it doesn't know what to do with it. But this is all pretty straightforward. Continuing on with that X and Y point, there are 4 variables that are special. So X is always going to refer to your horizontal axis value, and Y is always going to refer to your vertical axis value. Those are lowercase specifically, it is case sensitive. And so if you want to put position on your vertical axis, one way to get around it is do capital X instead of lowercase x. And then it does have polar coordinates built in. So if you want to plot in polar coordinates and use your angle theta from the positive x-axis, and you want to use your distance then r from the origin, you can do that, but it's always going to be that. And I find this one to be the more annoying one as a physics teacher, because I often want to use r as, say, the distance between 2 planets when you're doing Newton's law of gravitation. And if I use a lowercase r instead of it being that distance, Desmos is interpreting it as a polar coordinate. And so again, the workaround usually is a capital R, or give it a subscript. There's very easy workarounds for that, but it's important to keep in mind. And this mostly comes from the difference between being someone who's doing math and someone who's doing physics. So my recommendation there is at the bottom. If you want to use any of these 4 letters in a different context, I usually give them a subscript. So theta sub 0, that no longer is the polar coordinate. R sub cm for center of mass distance, that's no longer the polar coordinate. And so subscripts are the way to go. Capital letters can be an option. As a preference thing, I don't like them as much as subscripts, so both are workarounds. Is it possible to turn off the polar coordinates or Cartesian coordinates? No, it is not. They're both built in there. And that's the way it's going to be. Great question. They are both there forever. So we want to plot things in polar coordinates. I don't do much of that in my own classes, but I guess if you're trying to do something with circular motion, it might be helpful, or elliptical motion, but I tend not to do that a lot. But you have the option, which can be a useful tool also. All right, so special characters. I imagine most, if not everybody in this room is familiar with most of what's on this screen, but I did want to make sure that we had it somewhere that we could reference when we're doing work later on. And now that you have the PowerPoints, you can just go back to this table. But you're going to use, in particular, the underscore is how you're going to get letters for subscripts. If you put a number in after a variable, it'll automatically make it a subscript. So you can type x0 to get x sub 0 right away. But if you want x initial, you have to do x underscore initial. And then the caret is going to give you your exponents. The forward slash is going to be your fractions, and it's going to turn it into a top and bottom fraction as when it looks nice, it's great. Asterisk for multiplication. The tilde is the one that's probably new if you're not familiar with Desmos. If you want to do any curve fitting, a linear or a nonlinear regression, you just replace the equal sign with the tilde, and the tilde, if you didn't know, is to the left of your 1, and you got to press the shift key there. And that's how we're going to do our regression. So that's probably the new key to you if you are new to Desmos. And exclamation point is a factorial. And for absolute values, you're going to use the vertical bar, or also known as the pipe, which is right above the enter key. So you press shift and then the key above the enter key for your absolute values. That's all I want to say on that. You have this for reference. Most shortcuts you'd want are the things that make sense. You can do all your trig functions, they're built in. You'll notice that the font changes from being italicized to being non-italicized when you type in one of your trig functions. For a square root, sqrt, and it'll actually replace it with the little symbol, which is great. Nth root, I don't ever use the nth root option. I always just do fractional exponent, but it's there. Pi is built in, E is built in. The Greek letters alpha, beta, tau, and phi are there. And I almost always use phi for my angles when I'm not trying to plot in polar coordinates, because theta is already reserved for the polar coordinate variable. And I've got alpha, beta, tau there too. And then, so theta is special. It's not like the other Greek letters. It does special things. And then the ceiling, floor, and sine functions are useful when, especially if you're just hanging out for session 2, those tools can be useful when you're making animations. It can sometimes be helpful to have things happen in discrete steps, and your ceiling and your floor and your sine functions can help with stuff like that. See in the chat here, you can also use ABS to have absolute values, natural logs built in. Does the Windows plus dot work? I'm not sure what you mean by that. Maybe. And yes, in my so I'm 80% confident that what you see in this table is an exhaustive list of the Greek letters that you have access to. So no lambdas for wavelengths. That's the one I'm usually most upset about. But they have reasons for that. And the reason is in the future, they may want to use those for something. So for example, they want to keep the capital letter gamma in check in case later on they want to implement the gamma function into their tool. And so they do have a reason for it, is they want to keep them out of Desmos so that they could have access to those for special functions. But I don't love it. There is, if you Google Desmos Greek letters, you can find more of them. I would discourage you from copying and pasting from that for the reason I explained. At some point in the future, those letters may come to mean something else. I would hate to have your Desmos tool break because they changed the meaning of a letter. So I would go with what's there in default. All right, I think that's it. And then this is the source of my inspiration for these introductions. Let's see, and then we got a link there. So yeah, special characters, like I said, they do have more in this list, this page that May linked in there. I would tend to stay away from these. As much as it'll make your work look nicer, it could break your things in the future. It won't right now, it'll work right now, but it could break them in the future. All right. So that's our introductions. Pause for questions.
Yeah, Joe, I have a question about file management. To get started, like how do you organize everything? And I'd like to do it sooner rather than later, if that makes sense, as I'm building.
Sure. I am not the best person for this because my management is just save everything and hope I remember it, which is probably not what you want to do. But let's go to the graphing calculator now. We're here, and if you're logged in, all of your stuff gets saved in this menu over here. And so all the graphs that I have saved just exist in a running list of things. And as far as I'm aware, and someone who knows more could correct me, I don't know how much more organization you have besides that. So I don't know, I'm not aware of being able to add folders into your saved work. Does anyone have any more information on that than I do?
Well, if Jennifer was asking about how to save individual graphs, I think what you just showed is the only way. But if you're trying to save teacher activities, like the introduction activity you did, you need to create a teacher.desmos account and you can create collections there.
Yes, thank you, Amy. I appreciate that for clarification. So there are two separate things that are almost in some ways worth thinking about separately. There's the graphing calculator and there is the activity builder. And the activity builder can use the calculator is probably the best way to think about them, as they are distinct, but the activity builder has access to the calculator. And so saving things in a spreadsheet is not a bad idea, just to save the links, but that would be something you'd have to do. So can we explain the difference between our graphing calculator and activity builder? You bet. So the graphing calculator is a tool that you can get into very quickly and make a graph. So we're here on the graphing calculator right now. Let's say I want to make a line that has a slope of 3 and a y-intercept of 5. It'll make it for me very quickly. And maybe instead I want to have this as a function, f of x, and I want to know what the value of f is at 4. I can type in f of 4, and it tells me it's 17. So you can use it as a calculator right away. And you can then save these if you're logged into your account on the right. You can just save this as, should give it a name, example graph 2. All right, and so this is now saved. And this is, so for example, I have my students use this just on homework problems, and we'll do some practice with that. I have my students use this when making graphs for their lab reports, and that's sort of the purpose that the graphing calculator serves for my classroom. And the activity builder is separate, and I'll show you that now so you get a sense of it, and we'll look more at it near the end of our session together this morning. But if you go to teacher.desmos.com, that gets you to the teacher side of building and implementing activities. So I'll go ahead and throw that in our link or in our chat for us too. And just sent that to one person, not everybody. There we go. All right. And this is where you can save things in a way that's a little bit more organized because you're doing more advanced stuff. So the introductory activity I had us do this morning, I made through the activity builder. And if I go to my custom activities, we can find, let's see, which one is it? Welcome, right here. And this is what it looks like. You can assign it to a class, or you can have a single session code where you don't need people to be in a class to join. And you can see what it looks like, and you can see what it looks like for students with the student preview button. And let's see what else I want to add. But those are the activities right here. So you can hold them here, and if you want to add them to a collection, you have collections. So I've made a collection called Desmos for the Physics Classroom Workshop. I'll go ahead and, I was going to share this later, but while we're talking about it, this, you can see the teacher side of the activities we're going to do. Of course, I wouldn't share this with students, but I'm happy to share this with you all. But I plan on later today talking more about what this, or later this morning talking about what this teacher side looks like. And so this is where you can organize things into collections. So this collection is everything we'll use today and look at. And then if we go look at, let's say, collections I've added, let's look at Brian Frank's activity here. He has it organized with headers for different units. So we've got 1D kinematics, we've got forces and card sorts there. We've got momentum card sorts, energy card sorts. And so you can make a collection, and within the collection, you can organize it with subheaders. And so you have ways to organize your teacher side of Desmos with the activity builder and organize it nicely within collections, and then dividing up the collections. With the graphing calculator, it's just kind of a stream of consciousness saved in the order you saved it. And so that's our broad overview of sort of the two pieces we'll be looking at today. We've got the teacher side of Desmos, where we can make activities, store them in collections. And we have the graphing calculator, which you can use to make graphs, plot data, solve physics problems. And then if you want to share graphs, yeah, we'll be doing some practice with that shortly here. You can, this button is sharing your graph, export image. So we did with all my lab reports this past year were through Google Docs. We assigned through our learning management system, Schoology. You can do it through Google Classroom, of course, too. And the students would just upload that PNG image from into their Google Doc. All right. Can you create titles for, yes, you can, so you can do, so let's go ahead and shift into talking about graphing. So that's where we're at right now. That's one of our agenda items. So let's go ahead and introduce all of this. And I've got an activity for us to practice that skill too. So when making a graph, this is how I have students do it. Let's say, well, hold on, actually, let me pause for just a moment here. Let me grab, yeah, so let's go ahead and talk about what graphing looks like. Here we go. So if we want to graph, let's say we have that line again, y equals 3x plus, let's do something that, well, 3x plus 5. Y equals, it'll make you a graph. Some nice things about graphs is it will tell you intercepts right away. And so if I click here, it'll tell me the y-intercept's 5. It'll tell me the x-intercept is -5. This is especially useful if you are, say, solving a quadratic equation with a projectile problem. You can just go and plot that parabola, click where the x-intercept is, and it'll tell you values without any need for a quadratic equation. And I am all about avoiding the quadratic equation in some of my physics classes. So I think it's a good math skill. I don't think it's necessarily the best use of my time. Sometimes it is. I mean, it depends on your goals, right? So that's sort of step one. You can rescale. The wrench is where you're going to make your graph look pretty. I'll put it on display mode right now. This is what I would do if I were presenting on a projector that students can see it a bit better. It makes your font a bit bigger, the lines a bit thicker. I don't love the reverse contrast, but you have the option if you want it. And then you can change how your grid looks. You can turn off the minor grid lines, just have the major grid lines. You can have axis numbers or not. Sometimes that's useful if you're making graphs for test questions. Sometimes maybe you want them to label the axes or you want it to be a qualitative graph instead of quantitative. You can go ahead and just turn off the axis numbers. And then you can get rid of the grid altogether if you want. And then labeling your axes, of course, is super important. And you just do that with the add a label feature. So let's say maybe this axis represents time measured in seconds, and this y-axis measures, let's say position measured in centimeters. And so this graph over here now represents the motion of an object who has a speed of 3 meters per second starting at position 5. And then we also can, let's see, what else do I want to add? Our axis scale. This is usually something I have to teach explicitly to students. You know, usually in almost every graph we do, I want the origin in the bottom left corner, and I want it visible, and then I want it to be scaled. Oh, titles, you can't do titles. You can, there's a hack you can do, but I don't prefer it. You could put in just a random point and label the point with your title, but really I just have them put the title above the image in their Google Doc lab report. So they'll title it in the Google Doc and then put the graph in. So title's not an option. And so let's see, there's something below the wrench. Is that what I saw? I don't have anything below the wrench. Is there new things? That's exciting. I don't have them, which is sad. But maybe there's new features coming out. It's above the, I've got nothing above the ship icon too. Everything looks very standard right now. I don't know. All right. Anyway, scale. I usually very explicitly say make this like -1 or -5, something where we can see the origin. And then if we're doing data, I'll have them go 1 or 2 numbers above their highest data for each column. And so here, maybe let's just do 3 seconds of time, and let's do something where we can see all of that. So 15. There we go. And that's a decent looking graph. The name of the graph will show up above the graph when you export it as an image. So if you name the graph as, the graph title. Does it? I've never noticed that. So if we export an image now and download it and open that image file, and my picture doesn't have a title above it.
Never mind. It used to do that.
Oh, neat.
I guess it doesn't anymore.
That would be helpful. That'd be great if it had the graph title there, but it does not for me anyways. So you can use to make a graph. I also love doing this. For example, early on in the year, I know many people do a constant velocity buggy lab where you try to figure out where 2 buggies are going to collide, if you have one going to the right and one going to the left. And one approach to do this is to graph your position time data and find the intersection of those 2 graphs. And this is a wonderful way to practice this tool and then see it be implemented in real time. I'm going to change my variables here to x1 and t. I'll remind you I'm using x1 instead of x because it'll interpret x as the horizontal axis variable. I want it to be the vertical axis variable. And let's say I've got a second buggy whose position time graph looks like it's moving to the left with a speed of 2, and it starts at a position of 8. I can now use Desmos to figure out at what time will these 2 buggies be at the same point. And I can click here, and I can say at time 0.6 seconds, they will meet 6.8 meters to the right of my origin. And so you can use this as sort of where will these objects meet. This scales nicely to if one of the objects is accelerating, because you can put in the quadratic equation and figure out that point of intersection. And that is how graphing works. We'll look at graphing data next, but any questions on using the graphing tools that are here before we do? So you're not seeing the values on your graph. So you've got 2 lines graph and you can't see like a point of intersection. Are you on mobile or are you on a desktop?
Sorry, I just thought it was easier. No, I'm on a desktop. I can, when I put, I'm just not seeing where it says 10 and 5 and 0 and 1.
Yeah, so you do have to click on that spot and hover over it. Sometimes it does vanish very quickly. I had some students earlier this week struggle with that a little bit. So maybe it's a matter of, what's that?
No, I can see when I put my point over it. I mean, when I put my mouse over it, it pops up, but I'm not seeing like on the axes. I don't see labels of values on the axes.
Oh, so you don't see the like what I'm seeing 15, 10,
Right,
5.
right,
If you go to your wrench, you have the option to turn axis numbers on and off. So you may have detect that.
I'm so sorry.
No, don't apologize. Appreciate it. How responsive is Desmos for recommendations? I know Fed has been good. Oh, Desmos is great for teacher feedback and responding. They are all over that. We try to add a slider for T. We certainly can talk about that some more as well. Another way you might go about doing this is instead of graphing data, or in addition to graphing data maybe, you can put a value in for T. I'm going to just call it 1 right now. And we can and T will become what's known as a slider. And sliders are a really powerful tool in illustrating a lot of concepts, especially when you want to ask questions like, if I double this, what happens to this? You can really easily change values with the slider. And so right now I can see that t is no longer a variable. It's no longer being graphed in our graph over here. It's now a specific value because we defined it as a slider. To make that happen, all I did is say t equals 1 and then pressed enter. And I can shift my slider and change the value of t, and it will tell me what position 1 and position 2 are at whatever time t is here. So right now at t equals 4 seconds, the buggy 1 would be at position 17, and buggy 2 would be at position 0. And so one thing students like to do, especially early on in physics, is sort of guess and check as their problem-solving approach. And while I think it's useful for us to help them find more general approaches that are sometimes quicker, even if it is a bit harder with a bit more algebra, I don't think it's bad to use that line of thinking also with them. And this is a way to do that quickly, because is it 3.1? Nope, let's slide it over. Is it 2.8? That's not where they meet. Is it 2 seconds? No. And we can look for we can slide t back and forth until our positions match. And we can say, oh, so that intersection happens at 0.6 seconds. And so you can use the slider as a way to move time forward and backward, and you can press play and have it slide forward as well. And so you have options there in using the slider to compute things. This can also, this can be helpful too if we're doing, let's say, Newton's law of gravitation. I can make g 6.67 times 10 to the minus 11. I can make maybe m1 is 5 times 10 to the 24. M2 is, it might not let me do a slider with really big numbers. It might though. Let's see, if I change this from 0 to, let's make this between 1 times 10 to the 30 and 1 times 10 to the 40. So you can do slider between big values also. And I'll say the distance stays fixed at 10 to the 15. All right, so let me back up what we've got here. So I am ultimately wanting to do some calculations with Newton's law of gravitation. This is another place where Desmos shines because these numbers are very big or very small, and it can be very difficult to type it into your calculator correctly. And things show up in scientific notation if you type them in. I made big G the value of big G. I made M1 the mass of, that's roughly the mass of the Earth, I think, off the top of my head. M2 is some other heavy thing, and then R is going to be the distance between them. And if I want to compute the gravitational force, now I just have to type the gravitational force equation as we know it. I'm going to do F underscore G for gravitational force equals big G M1 M2 divided by R squared. And it'll give me whatever that gravitational force is. And I can slide this around and get some values. And so we can use our slider to try out different things, look at how things vary, and we can use Desmos to do calculations for us using equations sort of as we see them rather than trying to type in a bunch of numbers like that. So how do you get the slider again? You just type in anytime you want to define a variable, you just type in, maybe I want to make Q equal 7. That will automatically give you a slider. So you just have to define a variable with Q equals some number value instead of a relationship, and it'll give you a slider. You can change the range of your slider just by clicking on the left number to change the min. You can change the right value. with you can change your bounds that way. So you just click on the bounds to change them. You can also change the step value between them. So let's maybe I want this to go up by 2 instead of by smaller values. So I can only now go for the odd values there, 3, 5, 7, 9, 11, 13, 15. So you have the choice to change your bounds and the step size on your sliders as well. This can be useful if you want students to explore things. You can make a pre-made Desmos activity where the slider takes on specific values you want them to look at, and that's it. And then you can share the link with them once you've made it. All right, so looking through questions right now, will it show the graphs as sliders change? It certainly can and will, and that's what's great about it. We're going to look more at that a little bit later today with some of the analysis tools I have once we get our fundamentals down. But as a preview, let's use Q here. And let's say W equals QX plus 7. And so Q is now the slope of that line that you see there. Currently Q is 15. I can now make Q 13. I can make Q 11, 9, 7, 5, and 3. And that's what I've limited Q to be. And so when you're starting to look, especially at nonlinear relationships, but also linear relationships, when you're starting to really try to get students familiar with what different constants do in a relationship. So what does changing the slope value do? Having a slider is a really powerful tool because students can very easily see, oh, if that number gets bigger, my line gets steeper. If I want to add in a y-intercept, maybe b equals 6. And instead of WQX plus 7, I do WQX plus b. And I can now also shift my y-intercept up and down using the slider. Why don't big G, M1, and R have sliders? That's a great question. And as far as I can tell, the reason is because the numbers are so big. And so in order to make M2 a slider, I had to originally make it a small value because like it's adding in all those zeros right now. I had to make it something like 3. And then, I went in and changed the bounds. And so your sliders, if it gets too big or too small, it won't make a slider by default, but you can make that happen by making your bounds big or small in the values. All right, I think I've gotten all the questions. If I didn't get to your question, please go ahead and retype it in the chat. Yeah, very useful for teaching transformations of functions, you bet. How did I get the value 3.35 times 10 to the 14? So the way I did that is every variable on the right here is defined as a number above it or below it. There's somewhere each letter is defined as a number. I defined big G, I defined M1, I defined M2, and I defined capital R. And so you have to have those values defined. And once you've done that, you should be able to get a value. Yeah, so looking out for spaces between your subscripts, that's certainly where that'll get you for sure. That looks like we forgot to define an M2. Yep, that'll do it for sure. And then you get the little triangle warning sign, and you think, oh no, I thought I did that right. What's going on? Happens all the time. M1, etc. don't have sliders because they don't have subscripts. That could be the reason. Although 10 to the 15 also doesn't have a subscript. The capital R doesn't have a slider and it doesn't have a subscript. let's see. Question, if you type in an equation with variables in it, it will automatically ask you if you want to create sliders for them. That is correct, it will do that. It's getting a little bit messy now, but if I do y equals cx plus, let's do I, it'll ask me x and y because they're special. It won't ask you if you want sliders for those. But for C and I, it will. And so I can make those sliders automatically, and it'll create them that way too. So you can type in an equation which has variables, and then it will ask if you want to create sliders for those automatically. And you can slide along and make your lines do cool things. Superposition, yeah, go ahead.
Oh, no, I was just gonna ask it, but if there's a way to easily make graphs that have like a changing function by domain. So like, for example, if you wanted to make a position time graph where different things were happening at different times.
Yes, yeah, so like a piecewise function sort of a deal. You can definitely do that. Let's start fresh. All right, so if you want a position time graph that x1 equals 3t plus 4 to start us off. And maybe later on, you want that, maybe it turns around. And so x2 is going to be the next part of the motion. That's going to be equal to 4t plus, or let's make it turn around. So negative 4t plus 8, 10. Okay. So it turns around here, let's say, and that's what you want. You can say, all right, our time where that happens occurs at 0.857 seconds. I'm going to keep that in mind. I can plot the first part of this using curly braces and say, I only want the time values between 0 and 0. Did I say 857 or 75? 75, I think. And that will only give you the graph there for that part of the motion. And then for the rest of the motion, you can go from 0.857 is smaller than t, and t, let's say we end it at 4 seconds. Let's actually end it wherever this is. So 2.5 seconds. And so you can make your piecewise functions that way. There are other ways, let's see, 0.875, that's why they're not matching up. All right, other questions, folks?
Would there be a way, sorry, and now I'm just thinking of all the kinematics applications that I do at the beginning of the year. Let's say that you wanted to, is there a way to make those part of one function? I know it's not really a function, but so that
the answer I think is yes. I'm forgetting off the top of my head though.
So that if you were like, okay, here's car 1 and here's car 2 and they're different motions, but plotted in different colors.
So here is the syntax for that. Yes, you can. And usually with like the documentation for Desmos is very good. If you Google Desmos, what you want, usually you can find it. But here's what it looks like. So if you wanted to make a function y, which was sine of x when x is smaller than 0 and is 2x whenever x is bigger than 0, it looks like this. You go condition, colon, function. And that's how you make your piecewise functions, condition, colon, function. So let's take, the example graph is right here. Let's open that one up in a new tab. And here's what that graph looks like. So for every x value smaller than 0, the graph shows sine of x. for every x value greater than 0, the graph shows 2x. So you can make it all one function. Then if so, you're asking for kinematics. If I then want to look at y of -2, is that going to read it as a function? It didn't. Let's rename this y of x. No, it doesn't like that either. F of x, f of -2, it'll read the sine part of that graph. If I want f of +6, it'll read the linear part of that graph on the right. And so you can set up your piecewise functions this way, and then if you set it up using function notation, you can plug in specific values even with the piecewise function. And so if you wanted, turn around or something like that, you could put it all in one position time graph like that. We look at examples of sines and cosines. We can do that real quick as well. I'm going to turn this. I'll go back to this graph here. And I'm going to do two things. So let's go ahead and do that. So let's make phi our phase for our sine graph. And so let's make it, we'll do 360, we'll start off at 180 degrees. And the min value for that slider, I would want to be 0. And the maximum value, I would want to be 360. I also, Desmos is in radian mode by default. The wrench is going to set you up into degree mode, which is, again, where students make mistakes, right? You're in degree mode by default, or you want to be in degree mode by default. And so, or you want to be in degree mode, you switch it at the wrench. And let's see, what else do sine waves have? They have an amplitude. Let's make it 5. They have a either a period or a wavelength, depending on what's plotted on that horizontal axis. Let's call the period 7. And you can make your sine curve equal to, let's say, a sine 2 pi over that period times x plus pi, and it will give you your wave. I want to change this, I think, to frequency. Let's make this a frequency instead, and we'll do 2 pi f times x. There we go. And so if we zoom out a bit on our graph, we can see making the frequency bigger brings that wave in some. We can see decreasing the frequency spreads it out. We can change our amplitude. You can change your phase, shift it one direction or the other. It's a nice way for students to see how those go together. But I also want to show with this, and someone pointed out, they excitedly yelled, wave superposition. And you can do that, and it's very helpful. So I'm going to make, this first graph have every variable have subscripts 1. Then I'm going to do the same thing for a second wave. So I'm going to make a phase 2 equals 180 again. It will let that run between 0 and 360. I'm going to make an amplitude A2 equal to 5, we'll start off with, and I'll make a frequency 2 equal to, 3. And now I've got both 1 and 2. I'm going to make a wave 2 equal to amplitude 2 times sine of 2 pi f2 times x plus b2. And you can make 2 graphs. And let's say I want to add those, we can change your sliders on each. But let's say I want to add those 2 sine waves together. Now all I have to do is say y, I'm going to call it y underscore total equals y1 plus y2. And it'll plot the superposition of those 2 waves. And we can turn off the background waves, and we can see those waves added together. I can change the frequency of one of my background waves or the amplitude, and we can turn them back on and watch how they all play together. And it's especially nice for constructive and destructive interference. Yeah, so it is amazing and it is easy to do. Not only does it look easy, but it is easy. I want to, this graphs, or yeah, you can just beat frequencies with this. If you, oh, here, y'all will like this, but first let me make this prettier and then I'll show you something really cool. Let's call this ended up being sine wave addition. Right now, it made two blue graphs hard to see, and I kind of want the sum graph to be a little bit more emphasized than the other two. So I'm gonna go up to my edit list option here. And once I've pressed that gear that was up here, I can change how each of my graphs looks. So I kind of want the total, let's see, red and blue added together. I want it to be purple. So I've got a purple option. And you can change the opacity, is this one. It's a value from 0% opaque or totally invisible up through 100% opaque, so 0 to 1. And then you've got your thickness as well. So I'm going to make the total, instead of the default 2.5, I'm going to make it 3.5, a little bit thicker. I'm going to keep that opacity. But with the blue graph, I'm going to go ahead and make that one a little bit more transparent, maybe 0.5. And then the blue, I'm going to make that one also 0.5. And so they kind of fade into the background then, and they're still there invisible, but we can see the sum as being emphasized. And now that that looks prettier, I'm going to, I don't think I have one yet, add a time slider into this as well. I'm going to have it, we'll start it off at 0, but I'll run it from 0 to, let's say, a full period for wave 1. And so let's call that a full cycle would be like 2 pi f or something like that. 2 pi over f, or 1 over f would be a period. Okay, whew, math. So you can use already defined variables as your slider bounds. So 1 over f is the period for wave 1. I'm going to trade out my x's for t's. Oh, it didn't like that. I hadn't planned on doing this. Why didn't it like that? It didn't like that because t is a specific value is why it didn't like that. So phi, you want to make it maybe a linear function of time. So it changes over time. Let's do that. Let's make the phase of wave 2 change over time. So I've now got phase 2 being something that changes linearly in time. And if I press play, we'll watch that red wave move to the left. And then time's moving backwards now, so it's moving to the right. And so you can animate how changing that phase over time changes your red wave, which is moving, and then the sum wave there, which is the purple wave. All right, can't get back to the graphing function to turn back on. How do I do that? You may need to just go back to desmos.com. If you just are having trouble seeing the graph, the buttons here on the left turn a graph on and off. So this is to make the graph visible or invisible. It's these buttons on the left, and yeah, so click where there was a circle or isn't a circle. That should turn it back on or off. The buttons disappear. They just off to the side on your screen. Maybe you grabbed your browser on accident and shifted it off screen a little bit. Yours also disappeared? The little buttons disappeared? I've never seen that happen.
So on mine, Joe, I changed the opacity and I did the lines, and then I was in the middle of changing the T thing. I got T to be a slider. I added time to my two functions. I added time to my phi so that it would change with time. I have a play button on the time. The values change as the time goes through the scale, but I no longer have the colored dots indicating the function.
Oh, okay. So I know what happened, and I fixed that quickly because this wasn't in my plan. If you don't have an X anymore, it's just plugging in the specific value for time instead of all the values of X across the axis. And so it's plugging in one number instead of everything. So you need an X. So I had put a T in there, And my graph disappeared also, and the circle disappeared, because now everything, there's no variables left in here. Everything now is a specific constant value. So I put the X back in to make the graph appear. And I said, instead, let's go ahead and change phase 2 and have that be what evolves in time. And so the phase is now what's shifting left and right. Yeah, so that is my bad. Yeah, I did that and then changed it back quickly and maybe didn't emphasize that. X, you need something that's a variable that's not defined as a constant in order to get a whole graph. All right, so wave addition. It's nice, it's cool looking. And of course, you can get the special case then of if they have the same frequency. Let's make F1 and F2 both, let's say 1. Let's make this one, let's make them both 1. Come on, I'll type in 1. Hello. Make them both 1 and then move the phase forward in time. I'm going to make this go on just like forever. And press play, but let's do that slower. Let's, by the way, slower animations, this little button down here, animation properties, allows you to slow down the speed. So I'm going to slow it down quite a bit from what I saw there. And you can change how it loops back. You can have it go back and forth. You can have it just restart or just do it once. You have options in your animations here too. If we watch this, we can get 2 waves that are adding together. Let's see. I think this wave to also move forward in time, but in the other direction. I want a standing wave is ultimately what I'm after here. We're not quite there, but you can make standing wave patterns if you want to spend more time thinking about how to make that happen. But you can add up any graphs you want, which is really, really great. All right. Questions on graphing things? Once you have something like this, is there a way to share it easily? That is a great question. The answer is yes. So you've got to save it. Save button's up here. And then the little window guy here looks like an arrow jumping out of your computer screen rectangle is to share things. You can share things as a static image, which is what I do with lab reports, but also you can just copy a link to this page. You can also just grab the link out of the URL bar at the top. I usually go here for whatever reason. You can copy the link and then share the link, and anyone else can play around with this. And there, when you share the link with someone else, their edits won't show up on your end. So you can share the link with students and they can start playing around with the sliders and they won't interfere with each other and their work. And so you can share your work that way. This is how, if I share something I make on Twitter, this is how I go about doing that. I will say, whatever link you get here, I think someone pointed out in the chat, is going to be what it looks like at this moment. If you make changes after this, it updates the link. And so you'll need to share a new link with any changes you make. Someone say you can export as an animated good GIF. I'm not getting in the GIF wars here. It's a good GIF. No, you can't. That'd be cool if you could, but you cannot. If I do want a good GIF, I usually take a screen recording using the default screen recording software on my computer, and then I'll upload it to some video to GIF converter online. So there's not a default way to do that. The G in good GIF does stand for graphic, but I am not a believer that acronyms need to be pronounced the same way as the words that they stand for. I don't think that would stand up to scrutiny if you started looking at other acronyms. All right. Embed works great in Moodle, yep, and other LMSs. You can embed things. It does work very nicely. If you got your own web page, it gives you a little iframe link. The embedding is very nice. I have dreams one day of Google Docs allowing us to embed iframes so that students could embed their graph into the document, and then if they make changes, it updates automatically in the Google Doc. That is a dream for future hopes, but it does not exist right now. I pronounce girl with the hard G, but I pronounce giraffe with the soft G. So the GI argument doesn't work either. Okay. We've been going for a little while now, and I feel a computer break is in order, a screen break's in order. After the break, we will talk about plotting data, and using the activity builder, we'll do some practice with plotting data and curve fitting that data. So that's kind of what our game plan will be after the break. Once we finish that, we'll take our second break of the morning and shift into looking at the activity builder. So that's where we're headed. It's currently 26. Let's go ahead and we'll do a 5-minute break here. I'll put a 5-minute timer on our screen. I'm going to go grab some water myself, but I'll be back before the 5-minute timer is up if you have questions. So I will be right back. Oh, question, what timer am I using? That's not a silly question, it's a great question. I use this is probably the piece of technology, this timer, which is about to go off, that I use. All right. I use this piece of technology more than anything else in my classroom, probably. If we have a long block class, we'll do a 5-minute break like this. If I want a worksheet to take 10 minutes, but I know if they don't have a timer, they'll spend 20 minutes on it because they're goofing off. This goes up on the projector screen. And literally just go to Google, or if you're in Chrome, you just go to the bar up top and just type in timer, and it'll give you a timer. And then you can go full screen with it. You can change your time. It's great. It's very simple. I also love that you can do random number generator, and it will give you a random number generator. So if I want a number between 1 and 6, maybe we're simulating a dice roll. Give me one here, or you can number off your students and have it generate a number for them too. So yeah, they have a frequency generator. Like if I type in frequency, it'll give me like a pitch or something.
I've done like 400 hertz and then it's given me a play for that.
I'm just getting YouTube videos. That's less fun. But it works. That's usually how I do, just find a YouTube video of a tone. Yeah, random.org is great for student groups. I tend to use the spreadsheets, and I'll organize them on the spreadsheet. It gives me a bit more control, I feel like. But anyways, Desmos. Let's go ahead and get back at it. I want to fairly quickly, I think, show you how to graph data. And then I want to give you the opportunity to practice that in the activity builder. And so I have a under 5-minute YouTube video explaining how this works that I link on every Google Doc lab template that I have. And so students always have access to go back to the video if they forget how to do something. And students tend to be more willing to watch a video instructional tutorial than they are something to read. And they're more likely to view it, as it's immediately useful for them, right? As they need to do the lab report. But graphing data is super easy. Before we do that though, I did see a question that asked, how did we get the phi button? You just type in PHI and it'll show up PH, and then wait for it. I'm gonna type in an I, but you won't see an I, you'll see the letter phi. That's how all the Greek letters work. If I want alpha, A, L, P, H, right now it thinks I want 4 different sliders, an A, an L, a P, and an H slider. But if I throw on that last A, it becomes an alpha. And you have B, E, T, A for beta. Did I say gamma's in there? I don't think it is. Alpha, beta, gamma, alpha, beta, phi, theta, and there's one more they have, tau, T-A-U.
And pi.
Oh yeah, pi. So, tau, they're doing it as the 2 pi constant. I didn't know they had that in there. But yeah, you can do pi and it'll show up as the number, not just a letter. E gives you a number, 2.7. I think those are our built-in numbers. No delta. You know what? On the one hand, I'm bummed there's no delta, but on the other hand, we often use delta to mean change in or difference in. We're not using it as a variable itself. So delta x, Desmos would interpret as trying to multiply the value delta by the value x. And so it wouldn't read displacements or change in value the way that we would want it to anyways, I think. So I think that's okay. If I want to do a change, I usually do V underscore like 1, 2 to represent going from 1 to 2, or I'll do underscore change capital I in, or something like that, is how I might show a change in value, or just V change. Usually I go 1, 2, I think, for the difference between 1 and 2. But there is no delta. All right. I want to talk about plotting data. This is where my students use Desmos the most, especially this last year where many of them were on a computer. There are 2 ways to get a data table. You can go to the plus button up here and choose table. Let's point out everything that's here, by the way. The expression is the default value that's there on Desmos. Note is if you want to just write a comment saying, this is what I'm doing here, because sometimes, you know, your math may look a bit messy and you want to clarify in words what's going on. And so the note will allow you to do that. So for example, let's make a note that says, here I will show how to plot experimental data. There's a note saying that's what I'm doing. You can grab it. So you can grab a table from up here, and that will allow you to plot your data in a table. You also have the option for folders to organize things, and you can insert in images, which we were not going to talk about this morning, but if you're sticking around for the afternoon session, that adding images makes simulations and animations really fun. And so that'll be more useful for us this afternoon. Well, we've got the table. The other way to get the table, which is how I prefer to do it, is you can just type the word table into the bar, T-A-B-L. Wait for it. Right now it thinks I want 4 sliders, but if I throw an E on there, it'll give you a table. Column headings by default are X1 and Y1 for your first table, X2 and Y2 for your second table, and so on and so forth. If you want to change them, you can. If I want to make this T1 instead for time, and let's do velocity now, V1 for velocity, you can do that. I like to keep subscripts on there. It's not strictly necessary, but I like to leave the subscripts on for data. And let's say we have something that starts at time 0 from rest. So it has, well, actually that's not start at rest. Its initial speed is 3 meters per second. 1 second later, its speed is 3.5 meters per second. 1 second later, its speed is 4 meters per second, and so on and so forth. If you just type your data into the table, it will automatically plot. Can you indicate the units of measurement at the top of the table? No, you cannot. And the reason is that the table isn't made, its primary purpose is not made for humans to read it. It's made for Desmos to be able to interpret it. And so if you start putting in things like spaces and extra stuff like seconds and parentheses, it gets mad and confused at you. And in particular, parentheses, it's trying to interpret as the input for a function. And so that's why it's really mad at the parentheses in particular. So no, you can't, but as someone mentioned, that's what comments are for. T1 equals time measured in seconds. And let's add another note. If I write a note, does it make one for me? It doesn't. And then V1 equals velocity measured in meters per second. I'll use a quote to get the notes. I did not know that. Cool. Single quotation mark will get you notes also without having to go to the top. And as you can see, the data starts plotting as soon as you put it in the table. And it's wonderful. This makes a super nice looking graph. So usually I have students go through something like this. And as physics teachers here, we know this represents an object who is, what did I do wrong? I made this time not fit, okay. An object who's moving in the positive direction, getting faster with an acceleration of 0.5 meters per second each second. So there's your data. And it's really right in the word table. Change your table headings if you want, type in your data, it's there. Sometimes, especially if you're dealing with beginner graphers, this is too easy, right? That sometimes you want them to think about each data point a little bit more carefully and where it goes on the graph, and that's where graphing by hand comes in. That's the best tool for that. But once you feel confident that your students are comfortable with graphing by hand, of course, then you move on to computers to save them the trouble of having to do that every time. And this is great. Now, this would not be lab report worthy to me yet, because the points are only taking up less than a quarter of the screen that's there. And you can click the background and drag it to move things around. I usually do that to get 0 in the bottom left corner, but then we still have lots of white space. Let's see, do we have a question about the regression? Yes, we can do regression. So we'll get there in a second, and it's magical. I want to make the graph bigger first. That's my one thing I'm holding off on, but regression's coming up. All right, but I wanted us to be able to see it. So, and the regression's what's magical. Let's go to display mode. What I have students do is I encourage them to look in their table and be like, all right, T1 goes up to 5 at the most, so I'm going to make my max X value a little bit bigger than 5. 6 is a little bit bigger than 5. And I'm going to make my min X value -1. And then I go to my V table here, and I say, I want to keep 0 in there, so I'm going to make the min -1 again. But it goes up to most at 5.5. Maybe 7 is just a little bit bigger than 5.5. And now I see the origin and my data spans all the way across from left to right. Of course, we're not done yet. The wrench again is where I'm going to label my axes, add label, time measured in seconds, and velocity measured in meters per second. So while you can't put your units labels on the table, you can put it on your axis labels there. Unlike something like graphical analysis, it doesn't prompt for the units, and so you do have to intentionally put them in, but it definitely does. Look at the magnifier icon in the bottom left of the table. You can do what? Oh, neat. You sure can. It does get rid of the origin though, so you got to go back and find that if it gets rid of it. But otherwise, the magnifier, that's a great trick there. I didn't know that. If you look at your table, there's a little magnifying glass, and it'll do a zoom fit to your data. That's a slick trick. I like that. So a zoom fit here will do that. Now, the regression. This is where Desmos shines, is with the regression. If we want to fit a line of best fit to our data, I look at my table and I say that table heading is labeled V1, which is currently a 6-element list. While we're thinking about this, a little aside, if I want to grab the third velocity data, I could do V1 of 3. Oh, it didn't tell me that. There's a way to get there. Is it square brackets maybe? Yeah, square brackets next to a list, it'll grab the third data point in your list of 6 out of V1. Anyways, that's not what we're going to do though. What we're going to do is grab the tilde here to the left of your 1 key if you're not familiar with it. And I want to do a linear fit mx1 plus b. And it will give me the linear fit to that data, except it didn't like x1 because that's not x, it's t. There it is. And it will run your linear regression. It will fit the line to your data. And it is so easy. I have not found a tool that makes this easier, and that is why we use this for our graphing. You literally just type in the equation for the line, and it'll do the curve fit. Excel does that with trend lines? It sure does. Since Excel does graphing quite nicely, but in some senses, I don't know that Excel is made for graphing in the same way that Desmos is. And so I feel like the trend lines are just buried in menus and clicks and things. And that goes back to what I was saying earlier, is if teaching spreadsheets is one of your goals, and I think that's a good goal for a lot of students, I think it's a great thing to do. But I do think since spreadsheets are so much more powerful in being able to do other things, you got to find the graphing here. So this, I think for me and my goals, I think this it does what I want to do very quickly and easily. And it's, I think, generalizable. And so I'm seeing a few questions in here that I want to get to, but the one is, what about nonlinear regressions? You bet it does nonlinear regressions, and it does it exactly as people are indicating. You just type in the formula you want and with the tilde. And then, let's see, what was the other question I wanted to address there? How would I just connect the data points rather than a regression line? I will show you how to do that. So we'll do that first, and then we'll do a nonlinear regression. So first, I want the line to still exist, but I'm going to make it invisible. To make it invisible, I'm going to click on the blue circle here, and it goes away. I can bring it back anytime I want. The question was, how do I just connect data points? And why don't I actually go ahead and put a little bit of scatter built into this so that we can see a bit more of a scatter here. Something like that. Now this one's way off. Let's make this here. So it's still going to do the line of best fit through that data. Is there a way to save the table as an image? I have two versions of an answer to that question. One is not by default, but you can take a screenshot, and a lot of my students do that. The other thing, though, is you can, I think, oh, never mind, I take it back. You can copy and paste from Excel into Desmos. If you want to copy a table into Desmos, you can do that. I thought you could go the other way too and copy this table and bring it back into Excel, but it looks like the answer is no. Can we get R and R squared values? You bet, they're right there. They're using lowercase r squared and lowercase r, but they are there by default. Your R squared values are there. If you want a residual plot, you can get the residual plot too by just clicking it, and you can see that we're hovering around 0. There's a maximum number of data points you can copy, and I believe that. I haven't hit it, but I believe it exists. You're getting an error that reads subscripts may only contain letters. Interesting. I've never seen that. Subscripts may only contain letters.
Joe, I've had that error before, and
Yeah.
You can start typing in just any random subscripts, and then just erase some of what you typed until you get the appropriate subscript that you want, whether you want numbers or letters or some combination.
Yeah, so yeah, maybe just delete and go back, something like that. I will mention, this is where students make mistakes most often, is what's in your regression has to exactly match the table headings you're trying to fit a regression to. And students will often forget to put in the subscript. So they might just do a V instead of a V1. Yeah, maybe you're trying to use a variable that's already been used. So if you used a lowercase m for mass earlier in this same sheet, and now you're trying to use the lowercase m for slope, maybe that's where it's mad right now. Or similar with lowercase b. If you've used that somewhere else in this sheet as a variable, it may not be happy that you're now trying to use it as your variable for your fit. Let's see, can you use this for statistic features like binomial and normal distribution? There's at least a random value that you can do. I don't know much about, I haven't tried to, is my answer to that. I haven't tried to do some of those statistics features. I'd imagine some are there, but I haven't tried to, so I don't know. Yeah, Google Sheets is nice too. I'm looking through some of the comments now in the chat. You bet. All right. This would be, and I usually don't have them plot the residuals. This would be a plot I'd have students turn in, and our lab reports are all through Google Docs. And so they will share the graph, press the export image button, choose whatever it looks pretty to them. I tend to find the medium square at medium or large thickness is what translates well to a Google Doc. And you can download your PNG image, which can then be imported into your Google Doc. Let's do a quadratic relationship. I'm going to make a new table, table, and let's just go 0, 1, 2, 3, 4, 5, and let's go 0, 1, 4, 9, 16, 25. Let's zoom with our fancy new zoom fit button from Frank there. Beautiful. There's our data. Title can be done by labeling a coordinate point. I'll show that in a moment too. I don't tend to like that. I prefer to have them make the title in the Google Doc for their lab report, I think, but that is an option. But if we want to fit a quadratic to this, all we got to do is say, all right, I've got y2 is my variable for y2, shift tilde, mx2 caret squared, and there we go. And if you have fancier quadratic data than this, maybe you want to do a bx plus c. Why is it not happy with that?
Joe, what if it's not certain to be quadratic? What if it's quadratic-ish? Like, I was more thinking like inverse versus inverse square. If you don't already know what the expression is, what do you put in for your formula?
You could do, so I've got a few ways we're going to look at doing that. And one is you can make the exponent a variable and it'll fit the best exponent to it. So you can do a power regression like this. And so we can see that our coefficient A is 1 out front and the exponent B is 2. And so you can do power regressions. And so if you're trying to look at inverse E data and it's not known whether or not it's an inverse or inverse square relationship, you can do a power regression and it will fit that. Do I have a sample of a Google Doc lab report and can I share it, please? I was actually looking for one during the break and then we started things. So the answer is yes, I do. And let me finish finding one. Here we go. This was from our magnetic field due to a current carrying wire lab. I forgot the subscript 2 on my BX term. Oh, is that why I was mad? Oh, okay. That makes sense. So I will share both a blank copy of what it might look like, blank template. These are maybe a little bit more cookie cutter than I'd like, but I think it helps give some guidance as to what we're looking at or looking for. It was especially helpful this year. And I know I chose this one because I know I have permission from one of these students to share their work as examples. So let me find that real quick too. Yeah, going from subscript to superscript, underscore for subscript, caret for superscript. That's right. And if you're stuck in the subscript typing part of it, use the right arrow to bring your cursor back to being in the regular zone, and then you can do the caret. All right, and share. All right, so there's a student work example, and you can see their graph there. Oh, I didn't share I shared the blank template with one person, not everyone. Here's the blank template for that same lab report. And so you can see this student, they just typed the title in above the graph and followed best practices there, made sure all their data took up most of the space, everything was clear, axis labels there, all sorts of good stuff. And this is pretty much how I set up most of my labs. Like, this is a fairly flexible template that works in a lot of places. They have negative values. Who has negative values of time? On the Desmos graph that I have on my screen right now. Yeah. The fit will extend across all the axes. I don't think, but maybe you can just restrict it. I don't think you can restrict the domain on your fits. Yeah, so that is going to be, the curve will extend into the negative zone. You can't, can use piecewise with, well, what you can do is A and B now exists as variables. So you can make a new plot that says y equals ax to the b. Oh, it doesn't like that. Why not?
You need to put your values that you have. So it says a equals 1, b equals 2. So you need to put those.
Okay, so you got to do a 1 and a 2 there. They won't let you use 8. And then you can choose to say, all right, I want x greater than 0, and then turn off the curve that was made with the fit. And so you could have them manually choose their domain as well. Maybe I only want to go up to 5 seconds because that's where the data ends. Or maybe you do want to go out to 6 seconds, so maybe do some predicting on where it's going to be. So you do have to then go and make your own graph, but you can do your domain restriction there.
Yeah, it used to let you do the A and the B like you have it defined in the curve fit, in the regression, and then use those as variables later. It used to do that, but not anymore. I think because maybe students were doing like multiple fits, and then you'd have to have like an A1 and a B1 for your first fit, and then an A2 and a B2. So that A and the B, or the M and the, or however you define those variables in your best fit regression, those are just local to that there. They're not for the whole graph.
Gotcha, thank you. As I said, I feel like I had done that fairly recently where they existed as variables. So yeah, thanks for that clarification. That makes sense that students were getting confused on what to do there. All right. Other questions on plotting data? Can they just adjust the axes like you said at the start? Yes, they could. They could definitely. What if you bring this all the way over though? If you start the axes at time 0, the number 0 isn't actually visible, and the left axis gets kind of cut off. So that's why I like to start the left axis a little bit to the, or the horizontal axis a bit to the left of the vertical axis. So yes, you could do that, but it doesn't match up. So you're saying it's just one of those things that I look for. Does it match the reality? Sure. And a graphing calculator is not going to know the difference, right? So that's where you're going to want your students to make some decisions and thinking.
I just clicked on there's a little tiny question mark next to the parameters, and it linked to an article with all kinds of information about how you can adjust things and limit the range of possible guesses and improve your results. So anytime you see that little question mark, it's a good thing to check out.
Yeah, sweet. Thank you for sharing. I'm seeing reports that you can do regressions in the same line. And see, it feels like it seems to let you type it in.
You need
but
to
if
use
I-
X2.
Oh, that's why it's mad. X2. Okay, now it's happy. See, that's that'll get you every time. Is the right subscript. So yeah, okay, you can do the domain restrictions right in there. So if you want to just do between 6 and 0, you can do that right in there. So yeah, if you want your students to plot the data just where it's physically meaningful, certainly have them think about where that goes. All right. So with that, what I want to talk about next is different ways of how you might have students fit curves. So we've got this sense of what Desmos can do, I think. But the questions that I want us to look at is, so you're saying you're worried functions could scare them. I think that's a valid point, Nicole. And it's a wonderful transition into what's coming up next, which is how might we get students to think about these things? And I think I've got a few different approaches to think about. And I'm going to show you, I want to show, so linearization is one thing we often use, and Desmos does have a way to do that that's fairly nice. I am not going to be the biggest proponent of linearization being the way to do fitting to nonlinear data, especially when this feels easier than linearization to me. But if you're teaching an AP class, that's a skill that they need. And that's, I think, as far as I can tell, the only justification for teaching that at this point. But with this one idea I'd like to talk about and then give you some practice with is using sliders for curve fitting. And so I have an activity for us that I'm going to give you a chance to do. And I think it's a nice way to think about curve fitting with Desmos. It's not going to give students the least squares fit, this method, but it will get them to think about what different terms mean. And so, for example, so this is an activity I'm going to share with you all to get a feel for it. But I think one great way to do power fitting in particular, which I think fits most relationships you see, is to, instead of do the linear fit, just have a graph of y equals ax to the b, and then a slider for a and a slider for b. And this setup that's here is something you could have a link to that on your Google Classroom page or whatever your LMS is, that students could go back to and refer to every time they do a lab. So they plot their data. And the A slider here, right now I'm going from 0 to 10, but you could conceivably go higher or lower depending on your data. And the B, I'd have it running from -3 to +3 with a step size of 0.5. And so it sort of restricts the exponents to the types of exponents that show up in intro physics relationships. And I don't know if we ever really see something to the third power relationship, but I like my students to think about that, or at least try it. And what this allows you to do is see how changing those two variables, the A, the coefficient out front, and the B, the exponent, what it does to the purple line here. And so if I make B up to 1.5, I can see I'm getting closer to the curve I have here for my data. If I make it 2, maybe we're not there. Maybe we curve too much. 3 is definitely, 2.5 and 3 is definitely curving too much. So you have the students play around with first the exponent to try and get the right shape. As I make B into the negative values, I can see, I'm clearly not going to hit it with this data. But I want to try maybe 1.5 looks pretty good to me. Now I can try my A slider and try and get it to fit the data as best I can. That looks pretty good. But let's try it. The 2 looked pretty good too. Let's try moving my slider around here. And oh yeah, that seems to fit my data great. And so this is a tool I would use in sort of an intro physics class. I think rather than doing just the tilde power curve fitting, is at least at the beginning, have students think about how changing the exponent and changing the coefficient out front goes to fit your data. I'm going to go ahead and share this activity in particular. I'm going to assign it to our class right now. And I've got 4 different data sets there. I'm going to give you a few minutes to play around with that right now. And I think this would be a great tool also for that comment of inverse and inverse square look the same. And this is a great tool for trying to fit both inverse and inverse square relationships or curves to your data and seeing which one fits better. And so if you go to our class, student.desmos.com should get you there. You should be able to find this activity from the student end and just check that out. And this activity is 100% something you could give to students to practice. Like this is an activity you could use in the classroom. But if let's see. I want to view the dashboard for this, I think. All right, so we got half of us in, but if you get student.desmos.com should get you there. I'll give a few minutes for you to play around with manipulating the data that's present using those slides. I think this is the way to go when you're first teaching those relationships. I'll go ahead and stop my screen share for the moment too as you're doing that. You can also get to this activity from the student end by clicking the link that's in the chat. And you'll notice I did build this one with students in mind, because after they get their fit, there's a chance to share it or write the equation on the next slide, on the next page. Oh yeah, also, sorry, not sorry about this, but I did choose to plot spring constant in units of pounds per inch because I knew I had a bunch of physics teachers in here that'd be aggravated by that, and I thought it'd be funny. So that's there. As you go through this, I hope in particular that you notice the difference in the simple inverse to the -1 power and the inverse square relationship to the -2 power. To me, at least, as doing this, it's very clear which fits which inverse relationship better. And so it's a nice way to have students explore both. That's not too computationally like challenging for them. They can focus more on what fits rather than the software tools. So they can put their brain power to what you want them to think about. Notice that I can delete data points on the table. On one of the activity pages, there a way to lock items so students can't delete them is the question. I've never tried. Does anyone know the answer to that?
Yeah, Joe, you can actually hide when you're making the activity, you can
hide the data table, that's true.
Anything in a folder, so.
Yeah, so you can't hide it so they can't see it. That is true. And I chose not to do that on purpose here so that you all could see the data. But I don't know if you can fix things while keeping it visible.
Does each student have their own copy of the data table, or
That
if
is
I
correct.
alter it, do I affect everybody else?
You are only altering your own screen.
Okay. Okay.
Seeing a comment from Sam saying, I appreciate it. I still think linearization is good for understanding basic physical relationships. Yeah, so next we're going to talk about linearization because Desmos does that well too. And I'll give you a few different ways to think about that within Desmos. Will students be able to see this after the lesson, as in get a copy? Yes, it should be visible to them after the lesson. And so you'll be able to see the work you've done afterwards. So long as they are in a class like we are. If you make this just a one-off activity that anyone with the link can get into, then they're not going to get back to it in the same way. If you're logged in, you could. You got to be logged in though. Question, what does it look like on my end as a teacher? That's a great question. And that was what I was going to show next. And this is the perfect activity to demonstrate that. So let's go ahead and show that. I think we're ready to show that too. So right now, I'm sharing with you just the standard teacher.desmos.com page, which is how you got to get there, teacher.desmos.com. And I can go to my classes. These are the classes where I've set up classes for this past year. You all are this one. I can go to our assigned activities, and we've done curve fitting with sliders. So I've found the activity we've done. This is the teacher dashboard. And the teacher dashboard is what makes this incredible, especially for card sort activities. And let's see, the font on my screen looks faint, too thin to be clear, but only on the classroom activities, not the regular Desmos. That's interesting. You could change all of those. You could also choose in your graphs to make it display mode on your page, I think, and make that a bit more visible. All right, teacher end though. So here's the overview. We're on the summary tab right now. And the dot just tells me this student has done something on this page. So I can see who has done things on different pages. Some of you have chosen to skip over typing in the function. Yeah, totally get it. But we can see that very quickly and easily. This is a great overview to see, are my students on task? And if there's one or two students who maybe needs a nudge to get back on task, you have that nudge there. And we can then, I can click on any one individual screen. Let's look here at this piece of data. And it gives me an overview of all of the work that everybody's done. And we can see beautiful curve fits for our group here. If I want to jump in, let's say Kate's here. I click on hers and make it bigger then. If I want to leave Kate some feedback, I can just type in, great job. Keep crushing it. And send the feedback there. And you can do that on different pages. And so it's a great way to give some quick feedback to, without maybe having to speak to student out loud if they're in the classroom, or if they're doing this as a homework assignment when you go back to check it later on. And so you can go through that and click, and it's giving me a nice view of what everyone typed on the function page. Similar here, so it gives you the overview going one at a time. So that's what this page looks like. Some other neat features on this page that, depending on how you want to use Desmos, could be useful. You can make things anonymous, and so I could go through now, and I probably should have done that to begin with. And now all of you are mathematicians, so you can't. So I can show this screen, but we don't know who is who. And so this is great if you want to share out some data. This would be one way to do it. Do it in the activity builder, and this way we can just talk about people's data without maybe passing judgment to some individual students. Pacing is also a neat tool. I haven't found the need for it myself, just the way I use Desmos, but you can. So I could say, for example, I want you only to be able to see these screens now. And so now you're restricted to the first 7 screens. And this means students can't work ahead too late or too far ahead, or if you want them to get to a certain point and then pause and have a group discussion, and then later on, you can edit, or you can stop your pacing, or you can edit your pacing to let them move forward. So if you have key moments where you want everyone to stop and discuss, the pacing option is there. Yes, I see work in real time. It is not, there's no submit button. That's exactly right. So right now, if you were to change some of your things in this, is it the inverse square relationship? If you were to change some things, it would show up on my end. I don't know that you'll be able to find the activity by searching in Desmos. It's called curve fitting with sliders is what I called it. And then Desmos for the physics classroom is our group. But if you go back to student.desmos.com, you can find it, or here is the link again. You can also go to the collection link I shared at the beginning of the morning session, which has all of these in it from the teacher side. All right, crew. So yeah, for example, whoever's got Sophie Germain here, I saw they had a line for a minute, right? That's updating in real time. The Desmos search features are not excellent. That is the one downside to the activity builder.
It looked like when you held your cursor over the Sophie Germain, an actual student's name.
Oh, did it?
Yeah. When you, over the name.
If I went over here. Okay, so it does. So if you have your cursor over the name, if you're trying to keep things anonymous, keep that in mind, that it will tell you who the real student is if you put your cursor over it. All right. What does the camera next to the names do? It captures a screenshot of their work. Can you show us the overlay? What do you mean by the overlay button here? Like that. Puts them all on top of each other. It stacks it on top. That could be useful for lab data. So if you want students to take a few pieces of data, but they're all doing the same experiment, you could have them type in their data into a table in the activity builder, and then press the overlay and overlay everything on top. Now that said, I don't think this will let you do a curve fit to all of the overlaid data altogether. But another way this could be useful is, for example, if everyone's plotting their own position time data for their own buggy or something that has a different speed, you could overlay it and see, yeah, we all got lines, but maybe the slopes are different because they're moving different speeds. And so you can do comparisons and compare and contrast with the overlay. All right, folks, what I'd like to talk about next, and this will be the last thing we do before our next break, is different ways to do linearization. And I've got a practice activity that we won't have time for here, but it is in the collection of activities that I've made. But I do want to show how I would go about doing linearization type things in Desmos. So let's go ahead and make that transition now. I'll save the piecewise here. I want to open up a new graph for linearization. Now I'll show a few advanced table plotting features while we're at it. Let's make our time data. I want to make it a bit faster than I've done so far. I want to make a list of time values from 0 up through 10. To do that, I can use what's called a list here. So if you use square brackets, you make a list. And if I do 0, comma, dot, 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 comma, 10, it'll make a list of values that are from 0, 1, 2, 3, 4, 5, 6, 7, 8, up through 10. And let's say I want some position data. And I want that to be 3 times T1 squared. Now, X1 is an 11-element list where you take all of the time values from 0 to 10, you square it, you multiply by 3. I can now make a table, T-A-B-L-E, put in T1 at the top here, and it'll spit out those T1. Oh, it didn't want to do it. It didn't want to spit it out this time. Why not? I don't know. It'll do X1 though for me for sure. It'll spit out all the X1 data there. Sometimes this first column gets mad, and this is where linearization is kind of an issue. Let's call it T2 and retype it in. Okay, and we'll press our fancy zoom fit button. There we go. We want to do time in seconds and position in, let's see, these numbers look like centimeters to me. All right. Now, this was for quickly simulating data. Students would type in their own data if they're linearizing something. But what you can do, so to linearize this, right, we've got a quadratic relationship. So we need to, your data points aren't coming up. Yeah, the first column sometimes wants you to manually enter stuff. And if that's the case, you just got, I had to retype in data and I renamed it T2. The X1 data should work just fine. The right column should go ahead and put in that data automatically. Sometimes that left column is weird. So if we want to, so to linearize this, we need to square our time data because it's a quadratic relationship. And so we can make a new variable that I'm going to call T underscore squared. So this is a variable. It will store a list of all of the squared time data. And I'm going to assign it the value of T2 squared. So again, underscore to get that 2, caret to get to square everything. So T squared is a list of 11 elements, which is the square of all of those values. For example, if I grab the 4th element from T squared, it should be 9, because 3 squared is 9. And indeed it is 9. If I want to plot now T squared versus, or position versus T squared, which is what you're going to do when you linearize it, all you need to do is make an ordered pair that has T squared as the X data, comma, and then the position data I left alone, so that's still X1. X1. And it will plot your data that you've manipulated. And so the green data here are the linearized data for the black quadratic that we're seeing here. And that would be how you would go about doing linearization with Desmos, is you make a list of your manipulated data, and then you use an ordered pair to plot whatever it is you want to plot. In this case, it's the list of t-squared values and the list, and then x1 data stayed the same. Unlike a table, we can't do a zoom fit here, and so we'll need to manually choose our axis labels, but not our axis labels, our scale for our axes. But otherwise, this works well. And if you want to do your linear fit to this manipulated data, it's the same thing we've been doing. x1 tilde mt underscore squared plus b. And just like we expected, m is 3 because that's what I made it in the beginning of this demonstration, and the y-intercept is 0. And it's a perfect r squared fit. R squared is 1 because this is simulated data. Can you also label the axes in green to match the green graph? So that's right. If I were then having students make this graph, we'd go to the wrench. I would say time caret 2 measured in units of seconds caret 2. And I would turn off, scrolling up now, the black data points from the original parabola and just leave the green linearized data. And if we want only positive times, we just got to say we only want t squared values that are greater than 0. Why is it mad about that? You can find any region where this model is defined. Interesting. Greater, maybe I was greater than or equal to. Oh, okay, greater than or equal to. That seemed to work. Okay. And let's see, I don't know what my max t squared value is. So I'm actually going to type in max for max and t underscore squared. Let's see, it's 100. I guess I could have guessed that 10 squared is 100. So I'm going to make this maybe 110 for my x-axis value. And then for my y-axis, I'm going to look for the max of x1, which I already know is 300. And so we, oh, hello, back up. So we can make this 300. So you can use the min and max features to find the min and max of your data to figure out what's an appropriate scale for your axis. And that's what linearization would look like in Desmos, is you take, it's this two-step process right here. That's the additional piece. I tend to be of the opinion that this might be too slick for beginners at linearization, that they may miss the key points, but maybe not. Maybe because the calculations are done, they can focus on it. I'll let you be the judge of that. But this is the quick way to do linearization. And so once they get into the habit of doing it, then this is the way to go. I will highlight one of my other favorite ways to do linearization. Questions on this before I do, though? When do we use it? Always and often in my classes for the past year, because I've taught AP Physics 1 and 2 the past 2 years exclusively. And AP Physics 1, we'll start with accelerated mode, we'll start with acceleration, but when we get to acceleration pretty quickly, we'll do this exact graph that we're seeing here, talk about how the slope's half the acceleration. When we get into then Newton's second law, we'll look at linearizing the force versus 1 over mass. And yeah, like anytime we can, we do in AP Physics 1, because it's just a skill that comes up so much on that AP test. So yeah, 1 over mass is where we see it in dynamics. Let's see, thinking their energy then, I will do a lab where we do kinetic energy versus speed. So you got to square your speed data to get a linearized equation there. Yeah, in AP Physics 2, capacitor labs are a classic example here. Do I use linearization with non-AP kids? I have and I haven't. It depends on different groups. With my junior class, I definitely did as our way to manipulate data. Now, we were graphing by hand the whole first semester in that group, but yes, there was the same approach and the same method. And then we moved on to computers from there. I'm currently teaching a 3-week summer program for 7th through 9th graders. We're not doing linearization there. We are, for example, a place where we could have done is we're looking at light waves, and we did standing waves on a string experiment, and we could have plotted wavelength versus 1/frequency, but instead I just had them multiply wavelength and frequency together so that you go, oh my gosh, it's the same number every time, it's the speed. So I think it's a judgment call for your group. That's there. But we use it all the time just because it's on the AP test. And it's one of those things that for our students, in my experience, maybe 1 or 2 of them feels like they really get it, but everyone seems to have the procedure down by the end of the year. Maybe not until April, but by the end of the year, it seems like everyone's got the procedure down. You can put in a calculated column, but, so for example, I could go here, add in a 3rd column and do T2 squared, and it'll spit out all those numbers. What you can't do is then say, I want this on my x-axis. And that's why the ordered pair comes in. So you can't later on go say, I want my calculated column on the x-axis. This first column is always the x-axis. And then it plots every subsequent column as a function of that first column. And so yes, you can do whatever you want to your data. I don't know why you'd want to do this, but if you want 1/x1, there it is, and it'll calculate it for you, which is nice sometimes, but it doesn't do the types of graphing things we often want to do with linearization. So yeah, that's why, so yeah, this is the linearization trick for Desmos then. It's the ordered pair with your data. And I do think that's fairly nice, and I do think it works pretty well. I will say what you might want to do with students early on, I don't think this is a terrible idea, is, I don't want these columns, okay, is you may just want to have them at first square their data. Like, so if I spend any time with kids and early on this with Desmos, I usually just have them go in and type in 0 squared, 1 squared, 2 squared. And this is how I actually have them do it in the beginning, because it still gives them the knowledge that what they're doing is squaring everything in that first column. But it's a little bit faster still. So this is another way you can do it, is just have them do it for each thing. And this is still faster than doing things by hand. So I'd start here, I think, and then I'd move into showing them this shortcut after they feel good about just putting the square there. And I do feel that this is helpful. Let's see, so now this is t squared squared, so that's now to the 4th power. But I do feel that this is a nice way to do things, and sometimes more helpful, because this column with real data, just having more numbers in there, I think is maybe less informative than seeing that I took my original data point and squared it each time. This might actually be more informative as to what they're doing to see the exponent. Or if you want to invert stuff, same idea. You can just go through your data one at a time, and that's not letting me. But let me click anywhere. Oh, x1's calculated. That's why it doesn't let me manipulate it. But if I want to make a y3, and maybe the original data is 1, 2, 3, 4, 5, and you want to invert it just 1 slash, like writing this as to the -1 power, that's not bad. So I do like this, because I think actually seeing that you've squared your data can be powerful. All right, so those are my 2 linearization methods. Have them go through, type in the exponent or 1/, or whatever manually, or then once they get good at this, tell them you can speed it up with this process, sort of a 2-step process. Is Desmos limited to scatter plots? Yes. some people have done, I've seen bar and whisker plots, I've seen histograms. You might be able to do a histogram actually built in, but some of those are extra tools that people have built. All right, other questions on linearization? Is it not useful to type it? So you can, that's a good question also. Instead of making a list of t-squared data, you can just type in t2 squared here, and it'll give you the same plot as before. But I do need to now undo all of this squaring. Or, nope, this was 3. And it does work. You definitely can. The reason I don't encourage it is because that it doesn't then play nicely with your regression. You can type in t2 squared and get your fit, but it doesn't play nice. It fits a curve to your original data, not a line to your newly linearized data. So that's why I recommend the two-step process where you make a list and then plot it, so that the regression works better. Let's see, in the keypad under functions, you have options for stats. So you have some stats things in there, and you can do some visualizations too. So yeah, thank you, Frank. I appreciate that. So if you go to the keypad down here and then functions, someone asked about stats stuff earlier. Here's all your built-in stats functions, and then your visualizations are here too. So there are some other plots built in down below. That's awesome. Thanks. All right. So last thing I want to do is, before we end, which is approaching here in about 20 minutes, is to look at the activity builder from what does it look like to build activities. We've been staring at a screen for a while though, so I do want to give us a quick screen break as we make that transition. In the meantime, I will share it with you and assign it to our class. Some practice with linearization in there. There is a third way that's not as good that I decided not to show you. So one of these suggestions may not make sense. But if you want to practice linearization, here is some data with which you can practice. But do not feel like you need to, or feel like if you want to save it for later, that's an option too. But it's there and assigned to the class. Here is the link in the chat. Otherwise, we'll go ahead and take a short 3-minute break right now, and then look at the activity builder together. There we go. Let's see, I need to do a quick stand up and stretch break. I'm seeing in the chat that the link to Brian Frank's card sorts are only the physics 2 ones. Oh no, that's tragic. The physics 1, his physics 1 card sorts are were my lifeline this past year. So let me change that link. Let's see, you got 20 seconds left. I'll do it either during the lunch break or after session 2. It'll be done sometime today. Physics 1 card sorts, excellent, so good. Physics 2 ones are also, but I taught more physics 1 than physics 2. All right, crew. So now remaining time here, I want to give a tour of the activity builder. That's what the last thing that I want to show here is our tour of the activity builder. And the activity builder is where you can really be creative. It is very intuitive, much like everything in Desmos. You can I think it's very low floor to get started with it, and then a very high ceiling for what you can do. It's a wonderful tool. I know that in the registration form, I asked, what are some things you're looking to get out of this workshop? And I remember at least one person, if not a few of you, asked about the computational layer, which is a little bit more advanced than what I think this workshop is designed to do. So we won't be hitting the computational layer today. If we're interested later on, we can maybe look at talking more about that later on, or if you want to chat one-on-one. I'm not an expert in the computational layer by any means. I don't use it much, but I'd be happy to answer some individual questions if you had them. I will say the documentation on it is very good. And the few times I've wanted to use it, it was pretty straightforward to figure out what I wanted to do. I do want to give the tour of what the activity builder looks like, because I think once you see it, I think you'll be ready to go. So you should head to teacher.desmos.com if you want to play along with us and build your own activities. Oh, we've got one student who's looking for the social features. Bring it on. All right, we're in. Okay. I have to get permission for people to share out their thoughts with the whole class, which is a good thing. But we want customized activities. I want to build an activity with you all right now. And the new activity I want to build is up here. So new activity is top right corner. That's how you're going to build a new activity. I want to call this using the activity builder. Go. Your tools exist over here on the left of the screen. Usually I start off with a note giving directions. Here's where I describe the activity. Anything that's above the full screen line here, you can put multiple things on the same screen. So I could put a note there. I could put another note on the right where that note says, type your name in the box below. And then I could put a text input below that note. Note below the note, click and drag. And everything clicks and drags and snaps to a grid very nicely. And maybe I wanted a multiple choice question down here too. I'll suggest the multiple choices. The notes will be where you actually are phrasing your question if you wanted to do it that way, or you can use the header at the top. This is the header. Sometimes it's a description, sometimes it's a question. It depends on how you want to format things. I don't want that multiple choice anymore. So I'm going to press 3 dots and delete it. And so this is maybe what your first screen would look like. If I want to see what that looks like from the student perspective, I'd press preview, and there it is, right? Here's where I describe the activity, type your name in the box below, I'm Joe, and I can submit that. And you can edit your response. So very, very quick and easy to throw something together like that question-wise. If you wanted to do multiple choice questions, maybe you want to throw in a graph, and I want this to be y equals 3. Let's do 3 over x. And I want to restrict this to x bigger than 0 and bring it over here. So I'll make a graph. Of course, students cannot edit this graph. It's just there for students to visualize. And maybe I want a multiple choice question on the right that asks, or the question I can put at the top here. And I want to ask, what type of relationship does this graph show? And you can have direct or inverse maybe as your 2 options. Maybe you're just trying to do simple direct inverse type things. And there we go. And you can ask students, have a checkbox. You want students to explain their thinking on the multiple choice. It's right there. You want students to share their thinking with their classmates. That's what we did in our introductory activity this morning. You can click that second checkbox. If you want that just to be seen by you, then you don't have to. And if we want to preview this screen, I see the graph. I see I have no way to edit the graph. And the question's right up here at the top. What type of relationship does this graph show? I can choose direct or I can choose inverse. As soon as I choose that, it asks for an explanation of the thinking. It's inverse. As x gets larger, y is getting smaller. Is there a way to insert questions from other activities? Yes, so you can copy and paste from other activities. That is absolutely correct. That is what I did with our introductory activity. That is correct. If, yeah, let's see. If you select the right answer, it'll show a check or X on the dashboard. That's true for card sorts for sure. Let's see, so let's go with the multiple choice real quick. You could do basic buttons, you could do radio buttons, toggle, etc. You make it checks boxes, so you have those options. I forget with multiple choice, click the dot next to the answer. Okay, so you can also get a correct answer. So inverse is correct. There it is, thank you. If we go to preview, up here is where you'll see, direct was incorrect, inverse is correct. So dot for correct, X for incorrect up here. So you have, so it shows it right there. And yes, you can copy whole screens, but not individual pieces. That's correct. That is how that works. You can copy whole screens, but not individual pages. So if you want, that's one of the reasons I have, where is it now? Let me go back to teacher.desmos.com. That means there's more to this slide. Okay, green check mark then is fully correct. So if we go preview, you're not done yet. Here's a thought, submit. And there we go. If I don't have the explain your thinking, so your thinking could be right or wrong. That's why it doesn't give a check, right? I want that to be a teacher judgment. But if I go back and edit this without the ask for their explanation, and we preview there, X, still a dot. Is it still a dot? All right, anyways, that's multiple choice. I don't know why it's not a check mark right now. You'll get a check mark with card sorts if they're correct for sure. Importing from other activities, that is what I wanted to show. We can, so I wanted to go to let's see, oh, here it is right here. This was a nice example from Joe Cassette. If we want to open this up, which you can do with, so if you open up an activity you like, but you want to edit it, you go to the 3 dots here and you say copy and edit. It'll make your own copy that you can then edit. And if I want to grab this screen, I can, I believe, Control C, Control V, and yeah, Control C, Control V brings that in from the other activity. Oh, is it saying correct and correct because of the graph? That makes sense. But yeah, so all you need to do is open up the activity you like, make a copy of it so that you're editing your own, and then say, I want this page, Control C, back to the activity I was doing, Control V, there it is, it's yours. And you can make it however you want. Let's see, other features that are here. If you do want them to have the graphing calculator, that has to be full screen. You can't have multiple pieces together. Same with a card sort. The last thing I do want to show is card sorts and how they're done, because they are very fun. Although my real recommendation for card sorts is use Brian's or someone else's. That's my real recommendation. But if you're feeling creative, it is super fun. And the way you can add a card that is math or text, you can add a card that's an image, or you can add a graph. So if you want to make your own graphs, let's say you want to make a kinematics card sort, you can go ahead and say y equals 3t plus 2 for y greater than 0. And, oh no, for t greater than 0. And you'll get that line, label it if you want to, make yourself a nice card. You've got yourself one graph for the card. I tend to just, I don't make many of these, I steal them from people who do, and I love them for sharing them. But usually what I'll do is I'll make an image either in PowerPoint, or I like Google Drawings a lot. I'll download that PNG image and then just upload the image there. That's usually how I go about doing it. So let's grab this galaxy here. Now there's a galaxy card. And then maybe the text card is, this one doesn't belong. You can make an answer key. And these two group together, and this one doesn't belong together. That's our answer key. And now students will get a green check if they're right and a red X if they're wrong. So let's go ahead and look at that. Done. If I want to preview this page, let's see. If I group the galaxy with this one doesn't belong, I've got a red X up here. I didn't do it right. If I grab the galaxy with the graph, I now get my check mark. It is correct. So students have immediate feedback, which I love. The teacher view of this is great also, because you'll see the X's and check marks in orange and green. So you get orange X's and green check marks. And so you can quickly zoom in on who hasn't sorted their cards correctly and go in and give some feedback to them right away, or give them some questions that'll help them out. And so it's a great tool for you to get a bird's eye view of how your class is doing with the card sort. That's what's really powerful about it, is that teacher view tells you right away, yes or no, they're getting it or they're not. I am seeing some conversation in the chat, which is worth bringing up, that unlike things like Google Jamboard or Google Slides, which are collaborative, Desmos is going to be individual per device. So if you want students to collaborate, they'll need to be at the same computer, or sharing a screen in a Zoom breakout room or something like that. And we all know breakout rooms were the idea that felt good last August and then ended up just being terrible and awkward for everyone. But anyways, let's see. Does card sort only allow matching, or is ordering? Ordering is possible, not through a card sort though. So if we make a new page, you can, ordered list is one of your options, and you can add items there. I don't know if you can make images your options. So it may have to be words there, but you can do an ordering task. So what you may want to do is have, like, so for example, if you wanted to use a tippers ranking task, you may grab media and put it on top. Let's see, I want it on top. There we go. And then just take a screenshot of your tippers, put the image up here, and then your rankings may be A, B, C, D, and they can do the ranking task based on that. And so that might be how you could do a ranking task, is an image on top and then the actual rankings down below. What I will say is a bummer about the ranking task is that it doesn't allow for ties, which many physics ranking tasks do. And many people, thanks for pointing this out, folks, many people when making card sorts will just make one card that says greatest and then another card that says least, and then it gets grouped in with the pictures. So that I have seen it work that way. I'm also seeing some comments in the chat that both links to Brian's cards go to the physics 2. I'll fix that link during lunch. Question in the chat, do I recommend making separate Desmos classes for each section of a course, or just one class for multiple sections of the same course? I'm also curious about how and if you incentivize completing Desmos activities. I tend to like different classes for each section, but I think that's a preference thing. I think you could go either way. The reason I like that is because then when I'm looking at the teacher dashboard, I'm only seeing a dashboard for the students who are currently working on something, if you're doing it in class. If you're going to be using stuff like this as mostly homework assignments, which you can also do, maybe you want all your students in one spot, maybe you don't. So I like a class for each section personally. And then let's see, what about chemistry card sorts? I'm sure they're out there. I am sure of it. I just haven't had a need to seek them out, so I don't know. Let's see, and then let's see. I think that's all. Okay, I think that's all the questions. If I missed your question, if you could retype it for me, please, that would be great. Are the code names that are randomly assigned to students stay the same for each day? I don't use that feature very often, so I don't have the answer to that question. But it is a good one. I just it's not a feature I use very often to know. Other questions on the, okay, thank you, Andrew, for answering. The code names change each session. Other questions about this. So other question on the activity builder. It really is drag and drop, very intuitive on how to build an activity. I guess the last thing I'll say, let's publish this nonsense activity here. And if I want to assign it to students, I have two options. It's going to be under the green assign button though. Option one is you can assign it to your class. That'll be the default when you press that button. If, however, you don't feel like setting up a whole class, maybe like you're doing just one activity with a group of people you'll never see again or something, you have the option to do a single session code. When you click that, you have choices for how long the code will be active for. You can say, yes, students need to sign in, or no, they don't. And you can create an invite code. And if you do that, you can get a screen that looks like this. And then anyone can just go to student.desmos.com, type in that 6-digit code, and join the activity. So you can assign it to a class, or you don't have to. The other question I was seeing was incentivizing students. I haven't had to do much beyond this is different than what we've been doing online, and so it was kind of interesting for students. I think it's the same with any other type of non-graded activity. Your incentive is going to be having that relationship with your students and helping them understand that while this is ungraded, the feedback you're getting is going to be helpful, you know, as we go later on and eventually we do assess on it. Yeah, Frank, thanks for pointing that out. That is a good point to make. It is frustrating. You can't edit it as students are working on it. So it does need to be done well, but yeah. All right. That's all I have, and we're 2 minutes over. I'll stick around for a few more minutes if there's any last minute questions here, but I do want to go eat food also, and so I'll take a lunch. And if you're sticking around for number 2, we're gonna have a lot of fun doing activities and simulations. We didn't get to all the activities I built in, so feel free to check more of those out if you want to. And I am here to help out with Desmos beyond today. Shoot me a Twitter message, shoot me an email with questions, or share neat things that you make. I love seeing creations that other people make, and I love then stealing them and using them in my own classroom so I don't have to make everything. So share away, I'd love to see it. And so with that, we are done for the morning session, and I'll see those of you that are coming to the afternoon session in an hour.
Thank you so much.
You are very welcome.
Thank you,
Love
Joe.
the regression stuff. Thank you so much.
Yeah, the regression's great. It does exactly what you want to do in a pretty straightforward way.
Yeah, and it's good for my math classes too. I appreciate it.
Yeah, you bet. Thank you.
Yes, I just wanted to say thank you so much. I had never even heard of Desmos until this summer, and this is fantastic. I'm so excited.
I'm glad you're here then. Yeah, Julie, it's an awesome tool. It really gets to students doing things super quickly so that they can think about the science you want them to think about instead of the calculations behind it.
Exactly, and that's what I'm fighting right now in school. So it's like we're teaching physics, not basic math. I mean, yes, we're teaching math, but we need to teach the physics here. So
right,
yeah,
they go together, but it does reduce cognitive load so that they can focus on what you want them to look at.
Yes, so thank you.
Yeah, you bet. All right, crew, other questions that are out there? All right, hearing none, in that case, we're gonna end this Zoom. And if you're hanging out for the afternoon, I'll see you on that other Zoom in an hour.